Hi, friends. Mr. Rogers here, and I'm going to go over the water case study. I kind of knew I was going to probably have to because I kind of gave it to you, especially online students, without much direction. And I kind of want to see what kind of answers you guys came up with and how we look at data critically, because that's an important part of science is taking data and then actually thinking about what it's actually showing us and if there's major differences in between. And right away, when you look at the data, it tells a story, but it doesn't right away pop out at you. And I want to cover a couple of things that maybe got hidden and some of us missed. And I want to make sure that we all understand the same things that maybe the in-person kids got because they're working with me through it, and it's just how it is sometimes. So looking at the chart, we got Grayling, we got Lake Michigan, we got Traverse City. When you're looking at these guys, obviously we're looking at the month here, and you guys live in this area. You kind of understand the general idea. It's going to be warmer in July, and it's going to be cooler when you get into January and February. Okay, and you kind of see that with the air temperatures. That is consistent here. So, looking at Grayling, you kind of get the idea of the high temperatures. Kind of get the idea of low temperatures. Now, one of the big things that we missed the online kids that maybe the in-person kids got a little bit more because of me helping them a little bit was I want you to kind of look at the gaps here between the highs and the low. This guy's 26 and 8, 28, 7. Okay. Remember that. We're going to go Traverse City next. You can see the same kind of idea. It seems to be slightly higher in the winter. Like it's 45, 42, 33, 31. 57, 56 in October. Looks like 72, 70 in September, 28, 26. Like, so we got that way. But in the summer and looks like spring, it looks like sometimes it's a little bit cooler than Grayling. Okay. And then if we look at the low temperatures, it looks like there is not as much of a gap between the high and the low. For example, here, 26.8. We got 28.16. So that's only the 12 difference. Well, this guy is a 18-degree difference. Okay. Or another example, picks a different one. We got 75.54, 76.49. So this one's 6 degrees more of a difference in this one. And that is a big difference. It adds up over time. You gotta remember these are averages, so there's gonna be more days that are hotter and cooler and stuff like that. But for the most part, there's a difference. Lake Michigan, um, kind of follows the general trend that you'd expect, except it's slightly. I'm hoping you notice that it was slightly off kilter. I didn't see a lot of you guys pick up on that, and so I want this one. The main reasons why I wanted to have this video was because if you look here, the temperature even in June, even though it's 75 degrees here, it's 52 degrees. And the warmest month isn't even the warmest month for the air temperature. And even though it gets pretty cold in January and December, it's still relatively kind of warm. It's warmer than the air, at least. And that's one of the main reasons why we have lake effect snow in November, December, January, and a little bit of February. It's still even warmer than the air at that point, too. March, usually at that point, we kind of balance out and there's not as much lake effect snow. A couple years ago, that was actually not the case. It's the lake stayed pretty warm all the way through the winter, and it actually didn't even completely freeze over. And we got snow all the way until May, if you guys remember a couple of years ago. So, looking at the questions, explain the differences in temperature between Grayling and Traverse City. I kind of talked about, Grayling's a little bit warmer in the summer and a little bit colder in the winter, and there's a bigger differences between highs and lows in the Traverse Cities. What you notice about Lake Michigan's temperature? Obviously, it was skewed a little bit. It was running behind. That's because of water's property of high Pacific heat. It takes a while for water to warm up, and it takes a while for water to cool down because water resists change. Water does not like change. And so, therefore, it takes a while for water to get up. I mean, you guys are probably all gone to Lake Michigan in June. The lake is cold. And you guys are probably all gone to the lake when it was kind of cooler in the air and maybe it was a little bit warmer in the water. What do you notice about Lake Michigan's temperature compared to the temp in Traverse City and Grayling? Well, kind of talked about it. Kind of depends on the season. Sometimes it's warmer, sometimes it's colder. How is this connected to the water properties? Well, this is definitely high specific heat, high rate of vaporization. You can also kind of talk about that. Obviously, high rate of vaporization. When we talked about it in the notes, we were talking about water boiling, and it's kind of a hard thing to think about because it's taught to you guys so um matter of factly that water boils at 100 degrees, water freezes at 32, and that does follow that pattern. But when you're talking about molecules and you get really really small, and there's temperature fluctuations, there's things called micro boils and micro freezes, and so water can actually evaporate off even if it's not that warm. Like water evaporates off the whole year here. As long as it's a liquid water, it can evaporate into gas. So could be um, high heat or vaporization could be it too. You can make an argument that during the winter you could talk about ice being a less dense than the liquid, but mostly high specific heat. And could you explain how this might be connected to lake effects now? So I wanted you guys to take a gamble on this question. This was before I gave you guys the notes. So you can see during the winter months, the lake is warmer than the air around it. And therefore, the lake is going to give off more heat and it's going to lose more moisture and it's going to form clouds. And especially Grayling and us get dumped on with snow. Well, Traverse City doesn't because it takes time for those clouds to form and whatnot, but we're going to get so much more snow than them. And that's because of the lake taking a while to warm up and taking a long time to cool down. So I hope that kind of explains the ideas here in this case study. If you want to fix some answers and turn it back in, you're more welcome to. You can send it to my email. If not, if you're fine with your grade, then don't worry about it. And I'll talk to you guys later. Thank you.